All right, let's discuss more triangles. In these notes, we're going to look at three specific types of triangles and some things you can do with them. So first, we're going to look at isosceles triangles. Now, isosceles triangles are just triangles that have two congruent sides. So two of their sides are the same, and the third side is different. So we have two congruent sides, which are called legs, and a third side, which is called the base. So isosceles triangles, because they have two sides the same, they have these two theorems, the isosceles triangle or base angle theorem and its converse. So the base angle or just isosceles triangle theorem says that if two sides of a triangle are congruent, then their opposite angles are also congruent. So this means if these two sides are congruent, their opposite angles in the bottom corners, the way this one's oriented, are also congruent. And that's due to the relationship between angle size and opposing side length. But it kind of makes sense intuitively that if these two sides are the same, then the angles that form them are also the same. And the converse is true. If we have two angles of a triangle are congruent, then their opposite sides are also congruent. So you can get either one from the other. And we can use this to find missing values and write equations and things like that. So example 1a here says, find x using that theorem or its converse. Well, here, if we know these two sides are the same, then their opposing angles or opposite angles must be the same as well. So here we know that x is equal to 35 degrees because the angles must be the same. Slightly more challenging on example B here, we know these two angles are the same, and the third angle here is 70. Well, recall that the three angles of a triangle add up to 180. So I know if this one is also x, then 2x plus 70 must equal 180 degrees. So if I subtract 70, I get 2x equals 110. And if I divide that by 2, I get x equals 55. So that's using what we know about triangles and what we know about isosceles triangles in particular. Here's one that uses the converse theorem. We have two angles that are the same, so we know that their opposite sides must be the same as well. So I can write an equation where 10 is equal to negative 4 plus 2x because these two side lengths must be equal. And then I can solve that equation, as long as I add the correct number. 14 equals 2x. So if I divide by 2, x equals 7. Okay, so isosceles triangles have two sides and two angles opposite the sides are congruent, and you can use that fact to your advantage when writing and solving certain equations. Equilateral triangles are kind of what they sound, equa meaning equal, lateral meaning sides. Equilateral triangles have three congruent sides. So their three sides are the same. The theorem here, equilateral or equiangular theorem, depending on how you're using it and how you're naming it, a triangle is equilateral if and only if the triangle is equiangular. Okay, so that means it kind of goes both ways. A triangle is equilateral if it has three equal angles, and it's also equiangular if it has three equal sides. So it's kind of like the isosceles theorem and its converse. These sort of go together. We have either a triangle has three congruent sides if the angles are congruent, or a triangle has three congruent angles because the sides are congruent. In either case, an equilateral triangle has three congruent sides and three congruent angles. So we're going to do the same thing we did before and find x here. Here we have an equilateral triangle, so we know all the angles are also the same. And I could make this complicated and say this must also be x, and so 2x plus 60 equals 180. But I also know that all these angles are the same. So if one of them is 60, the others must be 60 as well. So x equals 60. For example B here, again, I have two congruent sides and two congruent angles. You recall from isosceles triangles, I have two congruent sides here, and so their opposite angles must also be congruent. So if I have these two sides congruent, I know their opposite angles must be the same, and so this angle and this angle must be congruent. And this third one was told to us, and so if three angles are congruent, I have three sides that are congruent. So we have an incomplete picture, but we can use the equilateral and isosceles theorems together to complete that picture. So I know these two sides are the same. Now I could have known that already. They're marked the same. But I do know that these are all congruent as well. So I know that 2x plus 10 equals 3x. So I'll solve that equation by subtracting 2x, and 10 equals 1x. And example C, these sides are all the same. So I know all the angles are the same. Well, they're each 5x. Let me add those up. 5 plus 5 plus 5 is 15x. I know that equals 180 degrees. So if I divide by 15, I get x equals 12. Okay, our final type of triangle we're going to discuss in these notes is called a right triangle. Right triangles have one right angle. That's a 90-degree angle. The longest side, which is always the one across from the 90-degree angle, don't know why that did that twice, is called the hypotenuse. And the other two sides are known as legs. So we have a theorem, which is called the Pythagorean theorem. A squared plus b squared equals c squared is the formula. And what it says is the sum of the squares of the legs, so that's a and b, if we square those and add those together, that will equal the square of the hypotenuse. Now there are all sorts of excellent ways to show and prove this theorem. We're not going to do any of that in these notes, we're just going to use it. So it says to find the missing sides of the following triangles. So for the first example, we have 5 feet as one leg, we'll call it A, and 12 feet on the other leg, we'll call it B, and we're missing the hypotenuse, C. So we can set ourselves up with an equation, 5 squared plus 12 squared equals C squared. Well, 5 squared is 25, 12 squared is 144, and we have c squared. So 25 plus 144 is 169. And so to find the missing side, I take the square root of both of these, and I get 13 for my missing side length. For example B, I have the hypotenuse, C. I have one of the legs, we'll call it A, and I'm missing the other leg. Oh, I suppose if we want to match the picture, we'll call that one A and B here. So if I need to find A, I've got A squared plus 5 squared equals 8 squared. So A squared plus 25 equals 64. So subtract 25. So A squared equals 39. So I have to take the square root of 39 to find the value of A. And if we use a calculator to do that, the square root of 39 is 6.24, and on and on and on. So this is an irrational number, so we can just round. The nearest tenth is fine for now, so 6.2 approximately is our missing side length. We could leave it as the square root of 39, but 6.2 is a much more useful number for our purposes. We're not continuing on to use this number in a problem. We're just trying to find a side length. So saying something is the square root of 39 inches, that's not very helpful. Saying something is 6.2 inches makes a lot more sense.